Hello students, coming to Java programming course for our academic year 2021, second BTech semester 2, R19 regulations, JNTK Kakinada. And currently we are in Unit 3, and we know that Unit 3 consists of two chapters, Chapter 1 Arrays, Chapter 2 Inheritance. And this Chapter 1 Arrays in Java of Unit 3 composed in 5 videos, and this is video 5, last one for this chapter 1 arrays in unit 3. And coming to the topics we're going to cover in this video is multidimensional arrays. That it means in the previous video we already discussed about this one-dimensional arrays, and in this video we are going to see two-dimensional, three-dimensional and n-dimensional arrays. And the second topic we are going to see in this presentation is arrays as vectors. And arrays, we know the properties of this one. This array organizes similar type of values or variables into one unit, and a sequence of memory allocated for this. And this vector also is a real-time organizing elements, and we use to represent these vectors. Arrays is the best way, and we see this one into this presentation. Okay, coming to this multidimensional, and this is the way of visualization representation of these 2D arrays, and this one is 3D array, and we'll see clearly how these multidimensional arrays can be declared and initialized, and how to process operations on the elements stored in this type of dimensional arrays. And coming to the first one, multidimensional arrays. And in Java, multidimensional actually arrays of arrays. So this would remember very clear to saying that multidimensional arrays is nothing but 2D. Example 2D is nothing but, it's a arrays of 1D arrays, like that. 3D arrays of 2D arrays, like that. We can construct multidimensional arrays, actually the collection of arrays into an array, right? Is here, as you might expect, look and act like a regular multidimensional arrays, and we'll see. However, there are a couple of subtle differences there, and to declare a multidimensional array variable, specify each additional index using another set of square brackets. And we know, indicating that the one-dimensional array, and we can use only one set of square brackets, but to indicating the more than one-dimensional, and we are currently considering those as multi-dimensional, and what type of array you are going to use, one-dimensional or two-dimensional. Based on that, we have to use some set of square brackets to indicating that dimension of an array. For example, here the following declares a two-dimensional array. That declares a two-dimensional array, and the name of the two-dimensional array is 2D, and here we use two set of square brackets, indicating that what is the first dimension size and what is the second dimension size we are declaring for this array of type integer two-dimensional array. And as usual, we use this equal to operator and new operator specifically for allocating memory of these two-dimensional specified here, and that specification is 4 for in the first square bracket and 5 in the second square bracket of this declaration, indicating that. And we know that this dimensions of two-dimensional array, and this is specifically for this indicating rows and columns of a matrix type. Like here it is 4, indicate that 4 rows and 5 columns. So here 4 rows and 5 columns. The array will look like this one. So here it is first row, second row, third row, and fourth row. And coming to the column point of view, first column, second column, and third column, fourth column, and fifth column. 4 by 5 matrix. 4 by 5 matrix. And in the matrix point of view, we know that the first value indicates the row of a matrix. Row is a horizontal set of elements. And this second value indicates in this dimension, that is column of the matrix. And here this allocates 4 by 5 array, 4 by 5 array assigns to it 2D. And we'll see example point of view. See here, internally, this matrix is implemented as array of arrays of int type. Conceptually, this array will look like one shown below in this figure, and it clearly showing you that this is nothing but four one-dimensional arrays. 4 one-dimensional arrays we are constructed here. 4 1D arrays. What is the size of each 1D array? Is size 5. Here it is the first value. We declared that array as 4 by 5. That it means of 4 1D arrays defined. 4 1D arrays with size 5 each. With size 5 each elements. So it is, if you observe this one, this is the first array of 1D having size 4, and this is another array, this is another array, this is another array, second array, third array, fourth array, like that. So here together we organize these array of set of single dimensional arrays into one called two-dimensional array. This is representation of this one given here. This 4, 5 values, they represent like this. This 4 is indicates row index 0, 1, 2, and 3. So these are the 4 index ranges here used: 0 index, 1 index, 2 index, and 3. In the same way, this 5 indicates ranges of index 0, 1, 2, 3, and 4 in column wise. So this is 0 index, 1 index, 2 index, 3 index, and 4 index. So for this 0 1D array, and we have all these index common in column wise. So this is 0 dimension. See, 1D array of 4 1D arrays with 0 index 0. So here in this first dimensional array, here 0 index is common in first row indication of the value, row value. Every here it is index 0 is common. And next one dimensional array with index 1. So having 4 column indexes 0 to 4. So here is 1 is common in every index position of row here, and column changes from 0 to 4. And like this, we organize this dimensional 2D dimensional arrays. It is collection of arrays of arrays. So 2D we are going to construct. So it is collection of one-dimensional arrays. Got it? We will see more with another example here. So this is two-dimensional array. The array indication that what is the size of this array? Clearly saying 4 by 4, 4 by 4, 4 by 4. So what are the indexes? It having ranges from 0 to 3, and this range is 0 to 3. So here this is row 1, row 2, row 3, row 4, column 1, column 2, column 3, column 4. So row value 0 to 3 and column value 0 to 3. So this way it organizes the elements. Here total 4 into 4, 16 integer values we can organize into this two-dimensional array. And here we are having the index values of that location and position of that element in the array. And this is the memory we are going to organize for this 16 locations of memory required to organize this two-dimensional array of order of size 4 by 4, 4 rows and 4 columns, total 16 elements. And these are the indexes of those memory locations or those elements to organize. The way of organizing elements in this two-dimensional array is row major order access. Row major order. That it means first whatever the value you fill into this array is row major order. So that is first element, the position given here, and immediately what is the next position to fill here? This is second element, and this is third element, fourth element, and after filling this row of index from 0 to column index 0 to 3, then it come back to the next element, the second row. This is fifth element, sixth element, seventh and eighth, and ninth, 10th element, 11th element of this two-dimensional array, and 12th element, 13 and 14 and 15 and 16th element of this location. And these are the indexes of those particular element going to access, right? Then coming to do understand well about this two-dimensional array of the program. So here in this main method, I have declared one array with two-dimensional of 4 by 5. So I'm needed, these are the indexes to organize. So the first for loop for row major order access, and I'm reading the values into this array of size 4 by 5. And second for loop, I'm taking column indexes, that is 0 to 5. These are the row index 0 to 4 and column index 0 to 5, nothing but 4, 0 to 4. And I'm reading whatever the value k from the keyboard, it automatically copied into these locations of the array. And we know this process from first year onwards in C language and C++ in matrix reading or matrix displaying, matrix multiplication, addition row. There we use this logic of statements for reading values into matrix of two-dimensional. And this is the logical instructions framed for displaying the array of elements of multi-dimensional, nothing but two-dimensional array elements onto the screen. So this is for row access and this is for column access, and we are displaying this value of this dimensional array onto the screen. Got it? And when we execute this program, it simply reads the value of that, what is this elements here, 4 into 5. So total 20 elements, 0 to 19. All these values are read from keyboard and display on the screen like this. This is first row, second row, third row, and fourth row, and 5 columns of elements. Right? Got it? When you allocate memory for multidimensional array, you need only specify the memory for the first leftmost dimension, and you can allocate the remaining dimensions separately. So this is also possible in the way in generally you are using here you specified both rows and column value indexes, but you can assign first like this also. So you can first specify the leftmost dimension and later you can specify individually about this one. For example, here this following code allocates memory for the first dimension of 2D when it is declared its size as 4. It allocates the second dimension manually. We are individually allocating. So first dimension, 1D dimension array size is 5, next one is 5, and third one is 5, 3 one is 5. Same, this allocates the memory same like this, here like this. But here the process is allocating second dimension manually like this. This is another way of allocating memory for these two-dimensional arrays. And you can give Individual separate size for columns, that is also allowed here. Example is this one. I given this rows as 4. So I given one row, second row, third row and fourth row. But the column size I'm specifying first one dimensional array with size 1. That it means only gives one column here and there is no second column for this one. And for the second 1D of this 2D array that it is specified to, that is one column and second column. And here it is 3 and 4 like this. So we will get some diagonal representation of the matrix below a triangle of this one. So this one also, this way also you can individually you can assign the dimensions for a second dimension for the two-dimensional arrays like this. Coming to the next one, multi-dimensional arrays point of view, three-dimensional arrays. And you can able to understand first 1D, 2D clearly. Then it comes to 3D. It is also looking somewhat logical. Okay. For you or for yourself to better understanding, I have taken this example. So for 3 dimensions, I have to use 3 set of square brackets here. 3 set of square brackets. And what it mean of this one. So the first square bracket set indicating this value is nothing but there are 3 arrays, 3 2D arrays, 3 2D arrays of size 3 by 3, of size 3 rows and 3 columns, right? Then what this indicates in 2D? Here this means there are 3 1D arrays with size 3. So you got it, this one. So we define this 3D array. We define this declared 3D array as 3, 3, 3. This first value indicates that there are in this 3D there are 3 2D arrays. There are 3 2D arrays. There are 3 2D arrays. This is array 1, array 2, array 3. And of this individual 2D array size is 3 by 3. This size independent. If you observe this one, this is 3 by 3 2D array. And this one like this, we have 3 2D arrays. And together we are organizing this as a 3D array of size 3 by 3. Got it? So this way you can understand, first of all, how to declare these multi-dimensional arrays and how these multi-dimensional arrays are indexed for accessing the elements. And if you confident and able to understand this one clearly, and these topics are very useful in the upcoming semesters in third year, and you can learn database management systems and data warehousing. There you are going to construct multi-dimensional data sets. There this type of representation is very useful for you, and a little bit make a concentration here to understand, to declare of these multi-dimensional arrays and try to understand the indexes values of particularly accessing some set of elements from this 3D 2D arrays. Okay, now coming to for your understanding, 3-dimensional array, how it is going to be look like. So I have created one a logical view for better understanding and better view to you. So here if you observe, this is one 3-dimensional array. Here it is composed of some set of values. So 3D array, what is the size of this array? Can anyone say like this? Anyone say about this one? What is the size of this array? 3D array. For example, consider here integer. For example, consider this as a. What is the size? First indicates how many 2D arrays there? 1, 2, 3, 4. Color indication clearly showing there are 4 2D arrays. So the first value is 4. That indicates how many 2D arrays there in 3D. and second set of square bracket indicating that, and followed by another set of indicating that what is the 2D array dimensions here. So that is 3 by 3, 3 by 3. So this is the actual declaration of the array for this. You got it? And if you observe this 3D array, I can just separate you one by one, just view the logical view here. So if you observe this one, this is table 1. Table 1 nothing but 2D array. This is first 2D array in this 3D. Like this, we have 2D arrays, 4 2D arrays. This is the second one, and back end, this one is second one, another one, this one, another one, and this one. Like this, we can make into together to form 3D array. This is logical view. Got it? Now I can separate individual element also. Just observe this one. So this is one element in this 3D array, and this one is second element into the 3D array. And this view should be understand by the computer science student, should have some logical view, and this way you can access the individual elements, and this view definitely helps you in the data mining, in the applying algorithms in 3D data values. Okay. Okay, understood. And then coming to alternative array declaration syntax. Actually, this topic was already covered in one-dimensional point of view, and for two-dimensional point of view also. Once again, I'm reminding you the way the arrays can declare. We know the basic general form of declaration of arrays of 1D, 2D, and 3D, but here is some alternative declaration for this one. So just go through this one. This is the second form of that declare an array, type of the array variable, and we can use these square brackets before the identifier or name of the array like this. And we can use this square bracket after the name also, as it is allowed. Right? This is second alternative way. Here the square brackets follow the type specifier and not name of an array variable, as it is allowed. For example, the following two declarations are equivalent like this. If you observe this one, so in A1 square bracket set equal to new operator and type of the array is specifying size. This is the one valid in initial declaration of an array in our general programs. And this can also, you can use this square brackets before this name also you can declare, and you can use this type of declaration also. It is also valid in Java. Coming to the declaration about two-dimensional, here also the same type of the array identifier followed by two set of square brackets and allocating size like this, as it is good. And the same way we can use these set of square brackets before this identifier as like this same, previous for 1D and this is for 2D. Okay, like this you can declare. This is considered as this process of declaration, an alternative way to declare arrays in Java. And coming to here, this alternative declaration form offers convenience when declaring several arrays at a time. Several arrays at a time, it is also be cool for us. For example, we are declaring 1, 2, 3 arrays of single dimensional, and generally we use this set of square brackets individually for every identifier representing that are 3 one-dimensional arrays we are going to creating 3 arrays. But we can use this second alternative approach by simply mentioning the set here, one set of square bracket here, and we can give this identifiers of the arrays by comma separated, and this automatically indicating that we are creating 3 arrays, right? This creates 3 array variables of type int. It is same as writing the previous one. This statement is rewritten like this: int nums. Here one set square bracket for indicating this one. Here it is square bracket indicating the size of this one. Here it is square bracket indicating that this nums s3 is a one array. And the alternative declaration form is also useful when specifying an array as a return type for a method. So that is also good. And coming to last topic, arrays as vectors. Okay, coming to here, vectors is nothing but a similar to arrays. These vectors are considered as another kind of data structure that is used to store information. In real time, these vectors in mathematical point of view, we already familiar this topic vectors. And coming to logically in our programs, when we are going to store information in a sequential format, and mathematical point of view, we consider those as vectors. And in programming point of view, we use this array data structure to represent these vectors or implementing these vectors in programming point of view. And using this vector, we can implement a dynamic array. And we know an array can be declared in the following way. And we can use this vector like marks storing, and size of this marks is 7 like this, and it is a value for declaring this marks as an array. And we know, but in Java is different case about these arrays and vectors. The basic difference between arrays and vector is that vectors are dynamically allocated, whereas arrays are statically allocated, and we can use size here. But here in vector point of view, the size of vector can be changed as and when required. But array is statically we allocate some size, and we wish to change. We already seen the topic how to change the size of the array when we wish to change at anywhere of your program. But this vector size is slightly somewhat different compared with arrays, and the size of the vector can be changed as we require at any new time. But this is not true for arrays point of view. And a vector class is contained in this package, java.util package, and we are familiar with this util package also. Arrays class also contains in this package, and this vector stores pointers to the objects and not objects themselves. This vector holds objects of pointers to objects, and generally we have this vector class in Java, and it holds that pointers to that particular vector class object. And here it is following a vector construction process. Here vector is a class and followed by object of this vector, and we can allocate memory to this using equal to, and specifically this new operator creates memory and allocates object and creates object of this vector class, and the size, and here indicating that it is 5. And if you observe here, parentheses are used, not square brackets, indicating the size of the vector. And that is the difference also between this vector and arrays. Got it? And this is simply we are taking the concept for understanding vector is a type of an array, and vector is also for storing the information, and it is the similar type of data structures as arrays. And in java.util package, we have a vector class, and we can create a vector for doing the same type of operation as arrays, and it is dynamically allocated. And here is the syntax to create object of this vector class and specifying some size to store how much amount of elements we can store into this vector. That is fine for this example. And these are the references for you. And thank you.